the shop. Today I want to show you guys valve cover modifications and the reasons why to do it. A few of the reasons would be, it's like naturally when you got an engine running, it's like you got the pistons going up and down, and so they're moving air on the top, which is in the combustion chamber, but it's also like it's also moving air below the pistons the same, and it pretty much cancels each other out because, you know, between all those cylinders in there, you know, one goes up, one goes down, so they kind of cancel each other out. You do get a little bit of pulsing, which is why you need breathers on normally aspirated engines also. But when you turbocharge your engine, you're actually, it's like you're running larger ring gaps. There's a lot more blow-by, getting past the ring seal, you know, especially when they're colder or anything like that. But then also, when you're like high on boost, the like cylinder pressure is also, I mean, it could be doubled, it could be tripled, depending on your boost levels. So there's even more gases getting by your rings in your combustion chamber. So if you don't ventilate that air from the crankcase, because it's coming like straight out of the combustion chamber, going around the rings and going down into the crankcase. And if you don't evacuate that out of there, it just builds a positive pressure inside of the crankcase, which could blow out seals and all that stuff. And so then that gets us to the next thing, which is why I increased the, so we're running two -10 lines coming off of here, and I may add an additional one down in the crankcase also if I need it. I should be fine with just these two, but like generally in an engine, the breather lines would run back to the intake, and your motor would digest them. So what happens there is you end up with long time use, you get buildup on the valves, on the intake runners. If you've taken apart an engine, you've seen it. It's that stuff on the intake runners, and it's just buildup. So that's coming from your crankcase vent. So that's the oil vapors coming up. So that kind of leads us to running a like breather tank externally, which like these lines would run directly to that tank, and that tank's gonna have baffles in it, and then a filter on the top, and that will eventually, I mean, it like can fill up if you don't have enough baffles and you got like a really bad blow-by. Then you actually fill those up, and you just gotta drain them periodically. So, and the other reason, so if you don't do that, if you don't run an external, and you just run these lines back into the intake, well, for one, you can't do that because your intake is now a positive pressure. There's no vacuum. Well, there's mostly no vacuum. There is still vacuum at like low RPM, but as soon as you get onto boost, it's going to pressurize these lines, and you're going to be pressurizing this with whatever boost levels you have. So that doesn't work. And also, I've heard that if you have too much, let's say, vapors coming up from your crankcase going into your intake, then you can actually lower the octane of your fuel burn and create detonation. So there's quite a few reasons why to do this. So if you're looking at doing this for your engine, like whether you have a 1SD or some other engine, it's the same, applies as far as the breather. Now, the second thing I did, I put a cam position sensor plate on the front of this because it was originally a distributor engine that I'm not going to be using anymore. So I got to put a cam position sensor in somewhere on the cam. So it seemed like people were doing it right here on the front here. So I'm just gonna do the same. And then after all these modifications, I powder coated it. And that was also to show that you don't need a fancy oven to powder coat. You can do it anywhere. So I kind of tried something new in this episode. I did not use an oven to bake this though. I wouldn't really recommend doing it this way, but I did get a good result. I was quite happy with it. So it does work. And part of the reason was out of necessity. I didn't want to go and like use somebody else's oven that's like large enough to fit this in. So I found a way to do it here at the shop without having to outsource, which is always good because you know, you got to keep the costs down on these builds. Unless you're made of money, like you really got to do as much of it yourself as possible because there's like so many parts that you do have to buy, like, you know, because you just don't have the means to do it. So I like to fabricate whatever I can. I like to go as far as I can into something on my own, and that keeps the overall cost down of projects, which I'm sure you could all agree with that's a good thing. So if you're not subscribed, make sure to do so right below so you don't miss any of the upcoming videos. We're just getting into the fun stuff now. There will be a lot more fabrication. I believe the next project will be the intake manifold, and I've been going over a few different ideas that it's going to be pretty unique, maybe. I'm not sure yet. Still just kind of like sketching stuff out. I got to get some components to kind of get an idea of what can fit. But so yeah, we're going to be building the intake manifold from scratch, all out of aluminum, and then following that up by doing the headers and all the turbo pipe routing. So without further ado, I hope you enjoy. So we're going to be using these -10 fittings that I purchased from Amazon. I can link those below. They're just -10 AM weld bungs, aluminum. So I made this cardboard template just to kind of get an idea of what to do and kind of like the sizing and which direction I wanted to run the hoses. Okay, so we're going to be using this like 1-inch quarter wall aluminum tube. I mark down the center and then just transfer the cut over to the aluminum to match the cardboard. I'm just going to be using the grinder to clean everything up and to like cut the bevel into it. You don't want to leave it like that though. You want to use either like a file or like you know, something that's not abrasive based, because the particles get kind of embedded into the aluminum when you use it. So after you've used the grinder, you just want to clean up with like a file or a carbide or something like that on the part that you're going to be welding, and then just clean everything with acetone real good to get all the grease off. And then just kind of Scotch-Brite it up just to kind of knock the oxide layer off the outside. So we're going to be using a Miller Dynasty 200DX. So you set the polarity to AC, and the process is, so you're going to put it on a high frequency impulse. Remote, you're just going to select remote standard because it's a pedal. Pulses per second and background amps, we're not going to be using any of that. Sequence, going to skip over that too. Post flow, that's already set. And we'll set the main amperage to 180 And then we're going to set the balance, which is the cleaning, to 75 to start with. So I'm just practicing on a test piece of aluminum. That's always good to test before you go to the part. You don't have to, but I'm usually out of practice, so it always helps me get back into it. And you can see there it did not clean very well. It was kind of sparking a little bit right there at the beginning. Now that could just be the tungsten contamination, but I'm gonna adjust the cleaning just a little bit anyway, which is the balance. It's like, so watching this video has actually taught me something that I've been fighting with for a long time, and I wasn't aware of it until I watched this video. So I pull the welding rod too far out of the gas when I weld. So when you do aluminum and you pull the rod away from that's like the gas bowl, it's still hot, it contaminates the rod with a like layer of oxide. And I've never known I've done it until watching this video. So it's kind of funny, after welding for, I don't know, like 15 years or so, it's like funny, you can still catch yourself out. Alright, so right here I'm just marking it at 90 degrees to the face where I'll be welding the fitting, which will square it up to the valve cover. Just going to go ahead and cut those both off. Get them clean, prepped. And you can see the gap in the middle there. So you kind of want a crater like that, so you can fill it in with weld. Yeah, so I just got it fixtured up here in a small piece of angle iron. When you're welding round things together, it's a good self-centering fixture. And all the other pieces of aluminum are just to kind of like keep it in place, because I couldn't really clamp it, so I just kind of rested aluminum up against it. It's like, you got to get pretty creative with how you fix your things when TIG welding, because you can't use your hands to kind of to assist you. And then when you start welding on it, if it's not held down and it's a piece of round, then it will just roll away, because like the filler material, when you push on it, will actually move your part if it's not held down. Like you can see right there. Yeah, so I'm going to work on getting a lens system made up for the camera so you can see the weld a little bit better. So this was just filmed with the camera by itself, so it's trying its best to auto adjust, but you can see it just kind of runs out. Alright, so coming back over to the valve cover, we're gonna pull these two fittings out of there, and they've been in there for a very long time, so the rubber has turned brittle. You know, I think when this was new, it would just kind of like squeeze out, like you could just pull it out because of the rubber seal. But because it's so old, it's just not wanting to do that. So ended up having to just clamp it with the vice grips and then kind of pry from underneath with a screwdriver. That was about the only way I could get it to budge. That worked pretty good. I actually did that on both of them, so it worked for the other one too. Yeah, so we just kind of laid out approximately where these things are going to go, so I could drill them out to kind of like match the inside profile of the pieces that we made. So now for the part that I've been dreading, cleaning it. But it's gonna pay off later on, so. Yeah, so just using a combination of different wire wheels. This little one on an impact works pretty good. But the wire wheel on the bench grinder helps for the bigger sections. Yeah, so here I'm just cleaning off all the casting burrs. There's kind of like a perimeter of these burrs all the way around. It looks really ugly, so I'm just kind of cleaning that up. And for this, I'm using a 50 grit roll lock. And so just kind of finishing off here with the same bit we used for the cylinder head porting in the last video. It just kind of cuts through aluminum really nicely. So they're not perfect holes, but it was, you know, like when you're going over something else, it's just kind of what happens. The goal is to let it breathe more air. Okay, so I'm just pulling out spark plug seals. I'm not sure what they're called exactly, but I tried knocking them through with a screwdriver. Don't do that. It just pokes holes right through them. So just getting the screwdriver up underneath it, just kind of rotating it, and they just kind of pry off. Let's rest this thing in place before we get started. And after you got one tack on, you can kind of, if there's any final adjustments that you need to make to it, like to the direction or angle, or if it's just not right, it's a good time to break it off, because you can just pull it off pretty easy. So you just want to square it all up. So you can see by all the smoke and the sparks that are coming off this that the aluminum is very dirty. So despite all of our efforts to clean it, it's just dirty, and it's gonna probably always be dirty. So at some point you just gotta move forward and just kind of deal with the potentially crappy weld that's gonna ensue. It's like welding valve covers off of vehicles that are 20 years old. It's probably one of the more difficult things in aluminum to weld, just because of the contamination level. And it's just kind of everywhere. It's in the pores, it's on the surface, and it's on the inside. So I think mostly what I'm dealing with here is the contamination on the inside, burning off, and the gases coming up and getting mixed in with the argon. Not much you could do about that, except like, I'm gonna cut them off and just kind of burn it until all the smoke stops and then weld it, but I didn't do that. I just kept going with it because this is a personal project. Alright, so the goal is to mount a camshaft position sensor up here in the valve cover, and to determine where it's going to be, you just want to be off center from the camshaft center point, because I'm going to have to build a reluctor wheel that's going to be attached to that camshaft that's going to be rotating. So since I don't know exactly where it's going to go yet, I'm just going to build a larger pad, this kind of general area, and it should work for later, because I'm not going to drill the hole until further in the build, but I just wanted to get it welded on before I powder coated it. So you can see, looking at it from the side profile, that the valve cover has a bit of an angle to it. I pulled the shim out of my toolbox. It's just a rear end, and it was 4.5 degrees, so that's actually pretty close. So I'm going to use that as so I'm using a 2" by 5/8. Just kind of roughly marking where I want to cut it. I don't know who keeps making all these messes. So I'm going to be using this facing mill, just because it's what I happen to have. If you don't have a mill, then you could just use a grinder for this. in place of it. It's just a little bit more sucky to do. But you know, you just always use what you got. That's the key. So you can see here it's pretty close to the right angle. I think it ended up being around like 5 degrees instead of 4.5, but it was pretty close. So it's actually sticking out too far, so I'm just going to cut a 1/4 inch off of it. So if you're making this for yourself, then just if you start with like 3/8, you're at the right thickness. Alright, so after shaving that down in the mill, remove that 1/4 inch. It's looking pretty good. I'm just going to mark roughly where it goes for cleanup, because I got to prep the material underneath. So this thing's just kind of sitting there, so I'm just going to get one tack on just to get it going. Okay, so you can see all the contamination in it. Like that black stuff in the weld, it's not supposed to be there. It's pretty nasty, so I'm just going to wire brush it. Move on. Alright, so with everything welded now, everything prepped, as far as the surfaces go, everything's cleaned. I cleaned everything with acetone. It's like this masking tape is specially designed for like powder coating, so it's like I'm not sure what temperature it's rated to, but it probably takes like 1,000 degrees to actually melt it. So it's because you can't use regular masking tape when you powder coat. If you're gonna do this at home, just get some of this for masking off. It's super cheap, so it's not a big deal. So I actually just taped off the filler, the thread portions of the fittings. So I like made these little hooks so I could like handle it. So like normally I'd be using this oven to do my powder coating, but it didn't fit the valve cover in there. So I made this little setup on top of the fireplace. I've never done this before. We're gonna find out how it goes, but I put a bunch of wood in there and a lot of bark, because like bark burns even hotter than the wood sometimes. So my goal is to get this thing roasted, and the heat coming up from it should be enough to melt it. Or at least help. Shop dog. This is Nico. And so we're going to be using this heat gun to assist. And it's a super high temperature heat gun. It's like for like vinyl lettering and stuff like that. So it's, I don't know what temperature it goes up to, but I run it as hot as it can go. Alright, so we're going to be using like dormant purple with clear coat over the top of it. So the powder coating system we're going to be using today is the Eastwood dual voltage. So it's got a high and a low, which is just for like different size parts. But we won't get into that today. But for most parts, you just put on 2 and you're good. So it's only sometimes you gotta drop the voltage. So there's a ground wire that you're gonna connect to the part. You just want to put it somewhere where you're not going to be powder coating though, if you can. And so you got the positive electrode on the gun, which as the particles come out of the bottle, they get charged from that electrode, and they're seeking the ground, which because you got that the ground connected to the part, those particles are attracted to the part that you're painting, and that's basically the way you get the powder to stick to the part. I'm using the fireplace for to extract the dust of the powder that goes past the part. So it's kind of a bonus, I guess, with doing this. But that's also why I'm sitting on the ground the way I am. So when you're using this stuff, you want to go pretty heavy on the powder. I've had more problems with going light than going heavy. Like, you probably can put too much on, but I haven't noticed any problem with that. I think you just kind of know when it's the right amount just by looking at it. It looks very uniform, and you know you've touched everything at least twice. So this powder goes on as like a lavender almost color at first, and then when it bakes, it like turns chrome. So you can see it changing from that like flat lavender kind of color to the like silvery chrome color. So like once it's uniformly chrome, then it's ready for the clear coat. So as you can see, the fireplace alone's not really doing the job completely. Like I'm really having to use the heat gun a lot more than I thought. So when you first start using the heat gun, you just don't want to blow on it too hard while that powder is still, it's not tacky yet. But other than that, just go nuts with it. It's like really hard to burn the powder. So I'm putting on the clear nice, so you can see how it goes on white. And then as it starts to bake, it kind of turns to that like silver. And then as the clear penetrates into the purple, I assume that's what happens at least, it starts to turn into that deep dark purple. Okay, so up until this point, I wasn't really sure how I was going to go, but it turned out pretty good, I think. Okay, so this purple color just doesn't really show the true color on camera. It's a lot darker and deeper in person. So there's just one more thing left to do now. So we got to grind off the powder coat off the lettering to reveal the aluminum underneath, which should look pretty good. It's one last time for me to screw it up now that it looks all pretty. So this masking tape is giving me troubles because it's like 20 degrees out in the shop. Okay, so I just put the tape down so I don't, just to kind of help keep me, if I slip off with the grinder, it won't slip up the part. So I tried with a gentle blue, like a worn out blue Scotch-Brite pad, and it just didn't, it was more just buffing it, like it wasn't aggressive enough. So I tried to use brown one, and it didn't work either. It worked better, and then I ended up getting out a new red one, and it started working a lot better once I did that. So I went over the whole thing with the new red one, and then just came back over with a slightly used blue one after that, like just to kind of polish it out, just to kind of get rid of the scratches. And that's it for this one. Just let me know what you think, and as always, if you got any questions, just hit me up in the comments and I'll do my best to answer. We'll see you in the next video.